In the last lesson, we talked about solving equations that have two operations in them, and so it took two steps in order to solve that equation. And if you remember, when we did that, we use inverse operations. So if you solve equations that have one operation, you use an inverse operation to isolate that variable. And if you use inverse operations to solve equations that have more than one operations. Now, in this lesson today, we're going to continue along that theme of having more than one operation. So sometimes you have to simplify the equation before you can solve for the variable. And the most common ways of simplifying are combining like terms or using the distributive property. Remember, combining like terms means that you add all of the terms that are the same, that have the same exponent raised to the same power or whatever, and sometimes that's just whole numbers and sometimes it's variables. The distributive property says that if you have a number on the outside, like a here in this case, multiplied times something on the inside of an equation, you have to distribute that of a times x and a times y. And then oftentimes what happens with that leads to us combining like terms. So let's do several examples with that. Go ahead and pause the video and copy these notes into your notebook. All right, so in this case, we have terms that are like terms. You have the 14n and a negative 7n. So if you combine these two, you have 14n minus 7n gives you 7n plus 2 is equal to 37. And then we can solve for n. So use inverse operation, the opposite of the inverse of adding 2 is subtracting 2. So you subtract 2 from both sides. The 2's cancel out. You're left with 7n is equal to 35. And this is multiplying. 7n is 7 times n. So the inverse of multiplying is dividing. So you divide by 7. And n is equal to 5. The next equation is 10x minus 11 minus 4x. Once again, we have like terms, 10x and the 4x. Because of the fact that we're subtracting, 10x minus 4x is 6x minus 11 is equal to 43. Split the equation in half. Use the inverse operations. The inverse of negative 11 is adding 11. So you add 11 to both sides. And cancel out the 11s on the left-hand side. You got 6x is equal to 54. Divide by 6 because that's the inverse of multiplying. X is equal to 9. In this particular equation, we just have it flipped around, and it doesn't matter which side we're on. Okay. So you have negative 3 by itself. You have a 4p and you have a minus 2p. So we're going to say 1 is equal to negative 3 plus 4p minus 2p is 2p. Split it. We're going to say plus 3 plus 3. The 3's cancel out. 1 plus 3 is 4 is equal to 2p divided by 2. And 4 divided by 2 is 2 is equal to p. Or you can write it as p is equal to 2. The next problem is one where we have the parentheses, and so we have to use the distributive property. So we're going to go 5 times m, which is 5m, and 5, so we have a minus. 5 times 2 is 10, Okay? And we have plus 36 is equal to negative 4. Here are the terms that we have to combine, a negative 10 and a 36. The 5m is already by itself. So 5m plus negative 10 plus 36 is 26 is equal to negative 4. So we're going to go minus 26. We're going to split it. Minus 26 minus 26. 26 is cancel out. We're left with 5m is equal to negative 30. Divided by 5. And m is equal to negative 6. Next problem. Once again, and here, once again, we have the equation, this expression on the right-hand side, but it doesn't matter. So 2 times x, remember, let's just bring down the 15. 2 times x is 2x. 2 times 4 is 8 plus the 3 that was already there. All right, combine these two like terms, we end up with 15 is equal to 2x plus 11. Split it. Minus 11 minus 11. The 11's cancel out. 15 minus 11 is 4 is equal to 2x divided by 2. The 2's cancel out. 4 divided by 2 is 2 is equal to x, or we could rewrite that as x is equal to 2. And one last problem. All right. The reason I wanted to do this is simply because of this right here. Okay. So you have that minus, but you don't really have a number that shows up. We don't really have a number that shows up in front of the variable. But we understand that this is a negative 1. Okay. Here's the little tricky part, is that if we rewrite this as 12 plus negative 1 times x plus 3 is equal to 10, we can see that we're multiplying both the x by negative 1 and also the 3 by negative 1. It's really easy to make the mistake of just multiplying negative 1 times x and forgetting to multiply it, the 3 by that. So we end up with 12 plus negative 1x plus negative 3 is equal to 10. So combine the 12 and the negative 3. So that gives us 9 plus negative 1x is equal to 10. We're going to subtract 9 from both sides. The 9's cancel out. We're left with negative 1x is equal to a positive 1. And then we have to divide both sides by negative 1. And we end up with x is equal to 1 divided by 1 is 1, and a positive divided by negative is negative 1. I wanted to make sure that I did a problem like this because this is one of those problems that is very easy to make careless errors on it. So pay attention, and if you have any questions, let me know, and